Hello, and thank you for joining me to this session about SiFive and our products. As most of you know, RISC-V is an emerging technology that was adopted warmly by the industry. RISC-V is a flexible architecture which spans from small and deeply embedded microcontrollers and up to high-performance vector-enabled application processors. In today's presentation, I would like to recap the available embedded solutions that SiFive provides and concentrate on the high-performance solutions we roll out this year. Let's start. For those of you who hear about SiFive for the first time, I'd like to outline the different aspects of our work. SiFive is the leading commercial vendor of RISC-V core IPs. This means that we implement the RISC-V spec and license the core IP. In addition to the RISC-V core IP, we also develop and license security IP targeting the RISC-V enabled SoC. Our second pillar is the silicon business unit, which Kitan, my colleague, will cover in the next presentation. And the third activity we are deeply involved is of course, the enormous RISC-V ecosystem in which we are a leading partner. The ecosystem includes work on software, hardware, and a lot of partnerships with other RISC-V Foundation members. When talking about RISC-V Foundation members, I'm talking about the leading semiconductor companies, EDA tools companies, and software tool companies. Some of them are customers, others are vendors, and others are users and contributors. The majority of the leading semiconductor companies both use commercial RISC-V core IPs and participate as a contributing member to the RISC-V Foundation and leading several technical groups as well as developing and pushing the RISC-V architecture to the next level. Now I would like to concentrate on SiFive and present you our portfolio. RISC-V is the only architecture which can span from edge to the cloud. And we at SiFive provide the full solution to capture all these segments. We have 3 lines of cores that we provide: E, S, and U. E cores are 32-bit embedded cores, S cores are 64-bit embedded cores, and U cores are 64-bit application processors enabled with MMU and RISC-V vector extension. The 3 core lines segmented into performance series. With 2 series, we target small and deeply embedded designs. The smallest possible 2 series core is around 13K gates. We have several pre-configured cores with 2 to 3 stages of pipeline, with or without tightly coupled memories, and with optional floating point unit. One of the unique cores that we have is the S2 core, which is a 64-bit small embedded core. Going to the next in line, 3 and 5 series, here we are adding the ability to instantiate several cores in one core cluster and the option to add instruction and data caches. The U5 is our U-class application core, has an MMU and runs Linux out of the box. The Unleashed board is powered by the U5 core, and it was the first in the world board with first in the world RISC-V core IP in silicon running Linux. The Unleashed board is powered by U54 multi-core, which is a core complex including 4 U54s and 1 S54 core. This gives the ability to both run Linux and a real-time operating system on the S54 real-time core. Progressing to the 7 series, we multiply the 3 and 5 series performance by implementing a dual-issue superscalar core for all segments. This provides very high performance embedded and application cores. The latest announced unmatched board is powered by a multi-core instantiation of the U74 and the U74 multi-core. The board is intended for PC-like applications and provides native RISC-V development environment. The next in line is the vector-enabled VI U7 core, the core based on the 7 series architecture and adds the RISC-V vector extension implementation in conjunction with the MMU. It enables to run Linux operating system and various artificial intelligence workloads like TensorFlow. The highest performance available core is the U8. It is an out-of-order 13-stage superscalar core. This core delivers above 7 spec-int and targets the HPC segment. The cores I've described in the previous slide are pre-configured with fixed feature set. In the case that you are interested to take one of the cores and customize it to your needs, we provide the SiFive Core Designer tool. It is a web-based tool which gives you the possibility to step through the different possible configurations and decide what is suitable for you. That way, you are customizing a core based on your needs and application. You have the ability to add or remove RISC-V extensions, configure the different ports and memories coming out of the core cluster, and decide which debug options you want to be implemented. At the end of the configuration process, the core is being generated on SiFive server, and you are getting an IP delivery, which includes the core RTL, documentation describing the core, and how to integrate it into your design, and an FPGA bitstream for several FPGA boards that we support out of the box. With the pre-configured cores and the SiFive Core Designer tool, we've shipped hundreds of RISC-V core IPs, and thus we are the most production deployed RISC-V processor IP vendor. We have customers in deeply embedded space like SSD controllers, in the wearable market with smart watches, and with different compute platforms like the PolarFire FPGAs from Microchip. With that, I would like to run through our different cores series. The first one is the 2 series. It is the most widely spread with hundreds of tapeouts. It is very configurable, efficient, and ultra low power. This core can be configured with different RISC-V extensions, including multiplier, floating point unit, and atomics extension. It can be configured as Harvard or von Neumann architecture. It can include an efficient interrupt controller, a debug module, and a tightly integrated memories. It can be integrated into your SoC using various system and peripheral ports, as well as a front port for inbound access. The next series is the 3 and 5. This series adds multi-core capabilities and also the first MMU-enabled U5 application processor. The 3 and 5 series adds the ability to instantiate several cores in one core cluster and adds caches to the core. This enables configuring instruction and data cache. The U5, as I mentioned, adds MMU and the ability to run Linux out of the box. In addition to the community-provided Linux, we also provide a complete tool suite to build a full Linux distribution from scratch. The 7 series is the highest performance commercial RISC-V processor IP available, and this is the series on top of which the VIU7 vector-enabled core is built on. The 7 series is configurable as the other series which we give, and this gives you the best control over the features you are interested in. It gives you the ability to maximize efficiency and power based on your design. Based on the 7 series, we've taped out a multi-core design of our application processor and manufactured the unmatched development board. This board has 8 to 16 gigabyte of DDR, several USB ports, 32 megabyte SPI flash, Ethernet, Bluetooth, and Wi-Fi connectivity, and all of this is in mini ITX PC form factor and intended for PC-like implementations. The unmatched board is powered by a multi-core implementation of our U74 high-performance core IP. The unmatched SoC called FU740 is featuring 4 U74s and 1 S7 core for real-time capabilities. At the last Embedded World Conference, Amazon, together with SiFive and Ajax, has demonstrated a platform for vehicle management based on the unmatched board. The demo showcased Amazon Greengrass IoT solution running on SiFive U74 core inside the unmatched board. As part of the demo bring up, Java virtual machine was brought up on the SiFive RISC-V core by Ajax. This is the first Java virtual machine running on a RISC-V and showcases the wide range of usages RISC-V architecture can be adopted to. Shifting to the vector-enabled core, the first vector-enabled core is built on top of the high-performance and production-used 7 architecture. This gives the flexibility and robustness needed for the high-performance vector-enabled products. Looking in depth into the vector-enabled 7 core, we can see that the core to which the vector extension was added is the U7 application core. This yields an 8-stage dual-issue superscalar processor with decoupled vector unit available in single or multi-core configuration and in various data path widths. This core can be configured to have different security components and advanced debug and trace features. The VIU7 core implements the RISC-V spec version 1.0. The RISC-V instruction set simplifies the development process in the sense that a single instruction set is spanning from the smallest microcontroller to the highest performance application core. The same binary can run across the board on all cores. The RISC-V spec brings a new vector approach and revolutionizes the vector-powered applications. And again, because of the wide community support, one can benefit from different open source frameworks available for RISC-V vectors already now. For example, the Java virtual machine. RISC-V vector extension is revolutionizing the legacy SIMD-based approach to vector computation. Based on an early research done by Dave Peterson and Andrew Waterman, one can see that already the early implementation of RISC-V vector extension is more efficient than other available SIMD implementations. This is thanks to the flexible vector length approach, which is in the heart of the RISC-V vector extension implementation. The extension adds additional 32 vector registers with length dependent on the architecture and spans from 128 up to 256 bits on Sci-Fi implemented cores. The strength of this approach here is the ability to control using software the vector length by grouping several physical registers into one long unit vector. This way, the instruction set instruction doesn't change. The same code can be used on different vector products. This brings a great amount of portability and ease of programming for this architecture. Going forward to the 8 series product, we meet the first out-of-order RISC-V Core IP implementation. The 8 series product is the highest performance out-of-order RISC-V processor IP available. The 8 series targets a wide variety of compute-demanding applications from edge to cloud. As other series, this core IP can be fine-tuned to meet the performance you are looking, and this is using cache configuration, addition or subtraction of floating point unit, and real-time capabilities tuning by disabling branch prediction. This core IP packs all the configuration options of other Sci-Fi core IPs and delivers better performance than ARM-comparable application processor like the A76. As a development platform for the VI U7 and the U84 cores, we provide pre-built FPGA bitstreams which target the Xilinx VCU118 FPGA. This is in conjunction with our software tools suite, provides a full development environment for vector and RISC-V based applications. Our software tools provide a complete software development environment. The Freedom Studio integrated development environment is our graphical user interface, which drives all other tools behind the scenes. We provide full suite including compiler, linker, and a debugger. We provide QEMU-based simulator as well as System C cycle accurate simulator. 2 SDK flavors are available as part of our tools. An eSDK package which targets bare metal development for our cores and includes a wide variety of software examples, several board support packages for the various platforms we support, both simulators and real hardware, and a hardware abstraction layer called Freedom Metal for ease of porting between the different Sci-Fi platforms. The additional SDK we provide is the USDK, which targets the application processor's development and provides a complete and comprehensive environment based on Yocto to build a full-featured Linux distribution from scratch. Using the SDK, you can build an SD card, load it into one of our development boards, and boot Linux. Thank you very much for joining me to this session, and I will be available for questions.